Action.
Good day, grade 11. Okay, so since yesterday we have started our topic, and which is electrostatics. Electrostatics, we are dealing with charges. Now, remember yesterday we've defined Coulomb's law in words. Then also we have learned about like charges and opposite charges. Now, for example, I have charge A and charge B. Between charge A and B, there's a force in between. So that force, we call it an electrostatic force. But now, charge A, since charge A is positive and charge B is positive, the force in between is a force of repulsion. Because now we know that like charges, they repel. Then again here, I'm having another example, which is charge A and charge B. Now, as you can see, charge A is negative, charge B is positive. So the force there is a force of attraction. Okay, that's what we have learned. And also we have learned about drawing a free body diagram, because our section today will be calculating the net force of a 1 dimension or 2 dimension using Coulomb's law. So now if we can check our diagram 1 and diagram number 2. So if you, number 1, if you want to calculate the net force, you have to know how to draw the free body diagram. So as you can check here, diagram B or diagram A is positive, diagram B is positive, and diagram C is negative. So we have to draw the free body diagram on diagram A due to B and what? And C. So remember, we have a force diagram and a free body diagram. So a free body diagram, you represent a free body diagram by what? Drawing a dot. So these dots represent diagram A. So let's check now the relationship between diagram A and B. Since B is positive and A is positive, so now the force there is a force of repulsion. So meaning now we'll have an arrow going down. So it's force on what? On A. So write AB. Then again, if you check here, we have your A and B, or C, C is negative and A is positive. So also here there will be a force of what? Of attraction. So we will have another arrow going down, meaning this one is force number 2 on A due to C. Yeah. So again, we are having another diagram here. The reason why now we are showing this direction is because a force is a vector quantity. So we consider the direction and the magnitude. So that if you can check, you have to choose whether your direction is positive or negative. So for diagram number 2, also we are checking the free body diagram for A due to B, C, and D. Now if you can write a free body diagram here, this dot represent A. So the relationship between A and B, A is positive, B is negative. So now we'll have our arrow pointing C. So which means this is our F for A and C. And now let's check again for A and C. Again, it's a force of what? Of attraction. So we'll be having another arrow pointing that direction. So it's a force between A and C. Then also again for A and D, you can see that A is positive and D also is positive. So we'll be having another arrow pointing in the west direction. So it's force between A and D. Okay, so our section for today will be calculating the net force or the resultant force using Coulomb's law. So our part here, it's electrostatics, force due to more than one charge. So since I gave you notes, you can see there, when there are more than 2 charges, every charge exerts a force on every other charge. To determine the net force on a particular charge, we add or superpose the effect due to all the other charges. So now, as I've given you the example, for example, for this one, as you can check here, we have charge B, charge A, and charge C. So what they are saying there, because now we are having more than 2 charges. So charge A exerts a force on charge B, and charge B exerts a force on charge C. Okay, A exerts a force on B and also on C. B on A, also on C. And C on A and also on B. So I want us to calculate the net force on A due to B and C. Pause that up. Go. Alright, I want us to look at this example. We have 2 diagrams, diagram 1 and diagram 2. They're saying consider the arrangement of charges shown in the diagram where we have charge 1, A, B, C. So our first part, I want us to look one dimension. So as you know, we have X and Y. X and Y. So here we have our Y, X here. So but now we're looking one dimension. Maybe we're looking at X charges on X, on Y direction, on X direction. So but as you can see, this one is a vertical. So we'll be dealing with one dimension. So in order for us to calculate the net force, step number 1, we have to make sure that our numbers here are in the correct unit. As you know that a charge, unit for charge is what? Is coulomb. So if you are given in microcoulomb, you have to convert. Nanocoulomb, you have to convert. Picocoulomb, you have to convert. But for this one, we are given in what? In coulombs. But our distance here, this is physics, you know that your distance is supposed to be measured in meters. So, but for this one, we are given in what? Centimeters. So we have to convert from centimeters to meters. Okay. So before we calculate there, let us change our units there, or distance. Pause. Okay, so now as you can see here, I've converted my units from centimeters to meters. You divide by 100. Okay, so I want us to calculate the electrostatic force between A and B. Between A and B, I'll be having my force between A and B. So my formula says K equals to FAB is equals to K Q1 and QA QB over R squared equals to, compose it out. Alright, yeah? So in order for us to calculate the net force, we have to draw our free body diagram. As you can see here, the relationship between A and B is attraction. So now we'll have our free body diagram going up from A to B. So now, okay, the second one is between A and C. You can see that there's a force of repulsion. As a result now, our sign here will go down. So also we have to remember that we have to choose the direction. So I've taken up as what? As positive. My first force was between A and B. So I take upwards as what? As positive. So as you can see here, I'm having my net force. Net force, the total of forces. So we have 2. We have force for A and B and A and C. So as you can see here, I've taken this direction as what? As positive, as upward as positive. So my force for FB is what? Is positive. And also for FC is negative. So you can conclude that if you are having a free body diagram pointing in different direction, here you'll be having a negative. But if your free body diagram points in the same direction, you'll be having what? Doesn't matter whether west, both west or north. If the signs points in the same direction, you'll be having what? A positive here. So here, as you can see, my force. So I've used Coulomb's law to find the force between A and B, and also to find the force between A and C. So this is my result.